Countdown is on track as we proceed toward T0. Once the rocket lifts off, it will take approximately 78 seconds to reach Mach 1, or the speed of sound.
$159.
Vehicle time.
55.
Launch sequence restart.
150.
Securing Centaur LH2. Securing Centaur LO2.
140.
FCS launch enable.
FDS arm.
T-minus 1 minute, 30 seconds, and counting. The launch vehicle, payload, ground systems, and eastern range are go for launch.
120.
Pump is on.
FCS count started.
110.
And valves locked.
T-minus 1 minute and counting.
Stable at step 3.
Status check.
Go Atlas.
Go Centaur.
Go GPS. 20. 15.
This is Atlas Mission Control at T-minus 10, 9, 8, 7, 6, 5, 4, 3. We have ignition, 2, and liftoff of the United Launch Alliance Atlas V rocket carrying the 8th GPS IIF satellite for the United States Air Force. GPS provides worldwide positioning, navigation, and timing services for the military and civilian users. You are hearing the voice of Rob Gannon providing launch vehicle ascent data. Let's listen in for mission progress.
Good there. Voltage yaw programs are in. Everything looking good. And we're continuing right down the center of the range track. 0.7 miles in altitude, 0.2 of a mile downrange, traveling at nearly 1,000 miles per hour. Engine continues to operate as expected. Flight control looks good. Rates are as expected. Engine is steady at 100% rated thrust. Everything is looking good. Roll program complete. Everything looking good. Continuing right down the center of the range track. Coming up Mach 1. Vehicle's now supersonic. Continuing to fly down the range track. Everything looks good. Engine is still operating as expected at 100% rated thrust. Flight control disturbances are good. We are now passing through max dynamic pressure. We have entered our second throttle phase. We are now operating the engine at 95% rated thrust, right as expected. And we are 10 miles in altitude. 5.9 miles downrange, traveling at nearly 2,000 miles per hour. Engine parameters look good. Vehicle is stable. Normal control on booster PU. And the vehicle is continuing to fly as expected. And we are now at 50% for our liftoff rate. Everything is looking good. Steering enabled. Normal transient for enabling steering. 95% rated thrust. levels continue to look good. And fire the power valve, activating the reaction control system on Centaur. Pressure's coming up as expected. Everything looking good. Next event we expect to see is throttling down the main engine to 92% of rated thrust in approximately 20 seconds. Now 34 miles in altitude, 55 miles downrange, traveling at over 5,000 miles per hour. And we've entered the next throttle segment down at 92% rated thrust, right on time. Engine parameters looking good, vehicle accelerating smoothly, good flight control, rates are smooth. And the vehicle is now 25% of its liftoff weight. Next event we're looking for is entering our constant 5G throttle phase. In this phase, the RD-180 will throttle down to maintain a constant 5 Gs. And we have now started boost phase chill down on Centaur. Preparing the turbo pumps on Centaur for firing. Everything is looking good. And we've now entered the final phase. The RD-180 filing a constant 4.6 Gs, coming up on booster engine cutoff. We have BECO, normal shutdown signatures. Coming up on staging, we have stage separation. Fired the retro rockets, pre-start and fuel, pre-start on locks. We have ignition, full thrust. Our L10 is up and running normally, everything looking good. Smooth start transient, and we have fairing separation. Both brake wires indicate a successful fairing sep. And our L10 looks good. We've gone to fixed angles on the Centaur PU system. Engine operating parameters reacting as expected. Vehicle rates looking good. Things normal. We've had our purge firings on the
This
reaction
is Atlas
control.
Mission Control at T+5 minutes. Rob Gannon has just confirmed payload fairing jettison, and all systems continue to operate nominally. The mission is in the first of 2 Centaur engine burns as the Atlas V travels in a northeasterly direction up the east coast of the United States. Our next event, Centaur main engine cutoff, will occur about 12.5 minutes from now. I'm joined now by Captain Kevin Pegelow from the United States Air Force Global Positioning Systems Directorate. Captain, thanks for joining me.
Thanks, Danielle. It's an honor to be here today.
Captain, can you start by telling us about the current status of the GPS IIF program?
Yeah, the 2F program is near completion with the launch of the ACE satellite this afternoon. We currently have 7 space vehicles on orbit, meeting all their mission requirements. Additionally, there are 3 more vehicles that are in storage, and the last and 12th of the GPS IIF satellites is in the final stages of production at the Boeing facility and scheduled to launch by the end of 2016.
Great. And looking to the near term, when does the Air Force plan to launch GPS IIF-9 using what launch vehicle?
Yeah, the 2F-9 is tentatively scheduled to launch in March of 2015, and the launch vehicle for that mission will be a Delta IV rocket.
Great. Given the functionality of the legacy system on orbit long beyond its expected lifetime, how does that affect the need to launch GPS IIF satellites?
Yeah, the legacy GPS satellites have remained operational well past their design life due to the high-quality systems engineering and mission assurance practices of that program. Although this has diminished the urgency to launch the newer 2F satellites, the capability to launch them still is strong to continue to upgrade the constellation and maintain that high level of accuracy required for the global positioning system.
Captain Pegelow, what made you decide to become an officer in the Air Force?
Well, I went to the University of Wisconsin-Madison,
Okay.
and so it was my sophomore year of college, and I was looking for opportunities of what I wanted to pursue in terms of a career.
Oh.
And so I was interested in the Air Force and ended up joining the ROTC program and then commissioned as an officer 2 years later, the same day I graduated college.
Wow. And can you tell our viewers a little bit about your background that got you the position you have today?
Yeah, well, I've actually had a very unique opportunity in the Air Force where I was given 2 career fields, the first as an intelligence officer and the second as an acquisitions officer. So I did my first tour as an intel officer working with the B-52 bomber for 3 years. And then at the end of that, I was given a list of assignments to transition to the acquisitions career field. And so on there, I saw working with the Space and Missile Systems Center, and it sounded interesting to me, working with satellites and GPS, and so I selected that and actually was selected to come to Los Angeles Air Force Base to continue that mission as an acquisitions officer.
And how does your current position contribute to the GPS mission?
Yeah, as a member of the GPS User Equipment Division, we are responsible for the acquisition of GPS for military applications to support our mission to deliver sustained, reliable GPS to America's warfighter and our allies around the world. Specifically, I work on the integrations piece as part of the integrations team to integrate modern GPS into aircraft, ground vehicles, weapons, etc. And then lastly, I'm part of the team to work on new initialization of GPS receivers. We're establishing a new process to initialize receivers and get them out to the warfighter into the field in a more quick and efficient manner.
That sounds great. Captain Peglow, thank you so much for joining us this afternoon, and thank you for your service to our country.
Oh, thanks, Danielle. It's been a pleasure to be here.
This is Atlas Mission Control at T plus 8 minutes and 20 seconds. We are approaching the end of the first of 2 planned RL-10 Centaur engine burns. The Atlas V and GPS satellite are flying over the North Atlantic Ocean, south of Greenland, about midway between North America and Europe. Our next event, the first main engine cutoff, or MECO 1, is scheduled to take place about 9 minutes from now. While we wait for the next mission event, let's take a look at the video highlighting the important capabilities of the GPS Block 2F satellite.
The Global Positioning System is a marvel of the modern age. It consists of more than 30 GPS satellites circling the globe over 12,000 miles above us. In tightly controlled orbits, these U.S. Air Force satellites continuously transmit their signals to Earth. An extraordinary technology, GPS enables anyone with a GPS receiver to determine the precise location and the exact time anywhere in the world, usually within a meter and within a billionth of a second.